Our next distribution is a chi-square distribution. This is called chi-square. Okay, it looks like X, actually, square in printed form, but it's not. It's a Greek letter chi, which looks like this. Now, the chi-square distribution is very interesting. It's actually, we're going to take a look at it later, that chi-square is basically our variance of the sample divided by this variance of the population. So, and that makes our chi-square distribution different from our normal distribution. How so? Well, first of all, this ratio is always positive. So there are no negative values for chi-square. So it starts with a 0 and it extends in a positive direction. Always. Its shape also depends on degree of freedom, just like with t-distribution, which in this case we're gonna call k. That parameter that it depends on, we're gonna call k. Now, as with any density curve, the total area is equal to 1. We already mentioned the curve starts at the origin and the majority of values are going to be closer to 0, and it's going to extend indefinitely to the right. So it's going to, we're going to say it's skewed to the right. And as the number of degrees of freedom becomes larger, chi-square curves look increasingly like a bell-shaped curve. So you could see that the blue line right here, it's with k equals 1, and the red one is for k equals 5. So the peak already moved a little bit to the right, but for k equals 10, the peak moved even more to the right. And yes, it's looking more and more like a normal distribution. So again, let's take a look how we're gonna use tools, statistical tools that we use in this class to find the chi-square to the left of 5.24. And also the chi-square with the area to the right of it, 0.05. For the chi-square distribution was degree of freedom 7. And also the example 2, we're going to look at the chi-square distribution was degree of freedom 12. And we're going to find the chi-square with the area to the left of it being equal to 0.01. Let's take a look.